folks. Good morning. Well, almost good afternoon. I know we are holding you guys up for lunch, so I'll try to go over my slides as quickly as possible. This is a translational panel, so I thought that I'll talk about two technologies that we developed in my lab to address the issue of PFAS in stormwater and groundwater. If I am doing this right, yes, I am. Well, PFAS enters stormwater through vehicular and other urban activities. So they are transported through the traditional drainage systems, the so-called green infrastructures, with pretty much no treatment, and enters surface water bodies unfiltered. So green infrastructures can partially remove PFAS, but some of the more soluble species can move through the soil column and get into groundwater, creating much longer term risks. So the technologies that we developed are two types of filter media that treat PFAS in stormwater and groundwater in situ. So one filter media is designed to treat both stormwater and groundwater. We call it the green granular filter media, or GGFM. So it can be used in storm drains and catch basin inserts to treat contaminated stormwater in situ. It can also be used as a filter media in permeable reactive barriers to treat contaminated groundwater. So there is a QR code of the patent here. And the other filter media is designed to treat stormwater in situ as a retrofitting material for green infrastructures like roadside rain gardens. This is the QR code of this patent. So now the question is, why are we calling these technologies green technologies? So this is because we are recycling an industrial solid waste that would otherwise end up in a landfill. These non-hazardous solid wastes are generated as part of a drinking water treatment process and are called water treatment residuals, or WTRs. So we are focusing on aluminum-based WTRs, or ALWTRs. So they are produced when aluminum salts are used for coagulation or flocculation, and they are sinks for PFAS. And why is that? The ALWTRs are primarily composed of amorphous aluminum hydroxides and oxides, and some iron oxides and hydroxides. And because of their amorphous nature, they have a large number of highly reactive sites. So the PFAS species are primarily composed of a hydrophobic fluorinated tail. And as Arjun told you, that's like carbon-fluorine bonds are the strongest bonds in organic chemistry. And they also have a reactive hydrophilic head. And that's composed of various functional groups. So these functional groups actually utilize the abundant reactive sites on the WTRs in the process of electron transfer. WTRs also have abundant organic carbon where PFAS species can partition. So moreover, the WTRs are free to procure. The only cost is associated with transportation and processing. And this approach is not only cost effective, but also environmentally sustainable and aligns with green technology principles. However, before we generate filter media from them, we must ascertain that these WTRs are non-hazardous. For that, we need to do a leaching test called the TCLP, which stands for Toxicity Characteristic Leaching Protocol, and analyze the leachate for acrite metals. So I show here the TCLP results of 8 WTRs that we collected for the purpose of our patent. The WTRs were all clean, all metal concentrations were well below EPA limits, most of them were below detection limits, confirming the non-hazardous nature of the material. In fact, in my 25 years or so dealing with close to 100 WTRs in the US, I am yet to come across one that can be classified as hazardous. So now back to our green technologies. The most effective filter media would be the WTR powder, similar to PAC, powdered activated carbon, basically drying the solid waste and milling it to micron-sized particles. The powder has excellent PFAS absorption capacity due to its high surface area and reactive sites. However, it's not suitable for field implementation. The fine particles, they lead to clogging and channeling under flow conditions. And to overcome this, we granulated uh, uh, the WTR powder using a low cost and green method that you can get from our patent. Although the surface area reduces quite a lot, almost half of it, like half of the powder, the hydraulic performance improves significantly with about a 30-fold increase in flow velocity. So allowing water to flow is obviously very important both for stormwater and groundwater. So here is a comparison of the hydraulic conductivity of our granules with that of some of the most commonly used commercial PFAS sorbents. Among the commercial filter media, Filsorb 400, which is basically granular activated carbon, has the highest conductivity, which is about half of the material that we generated. And this is, okay, all right, there was a animation here which got lost. Anyways, so the granular WTR, they show strong adsorption performance with very high removal of P4 and PFAS. So when tested under flow conditions, the granule packed columns, again, there was another one, animation here. You could have seen that the granular material, this column maintains stable hydraulic behavior, whereas this one showed clogging and channeling issues. So we extended this concept further to generate green engineered mulch, or GEM. So all green infrastructures need mulch for vegetation to survive. So we thought that how about coating the mulch with ALWTS so that they don't not only just provide nutrition to the plants, but also acts as a PFAS and metal filtration media. And that led to the development of GEM. They can be retrofitted in roadside GIs without the need of any structural modification or soil mixing. A field study in a roadside rain garden in Secaucus confirmed the presence of 40 PFAS species in the stormwater runoff. So at this time, using USCPS 1633 method, we can actually quantify 40 species, and all 40 species were present in your regular stormwater. So we have already field demonstrated both field technologies, these green technologies. GEM has been applied to 2 rain gardens in Secaucus. The granules have been deployed in stormwater systems, such as catch basin inserts and culverts this one is in Brick, this one is in Egg Harbor, and also in Hoboken. And field monitoring has consistently shown effective removal of PFAS, as well as TSS, metals, and hydrocarbons and phosphate. So I will stop here now, and maybe during the panel discussion, we'll get an opportunity to talk a little bit more about these technologies, and then we have this session, I think 15 or 16 out there. So if you have any questions, I'll be happy to answer at that time. Thank you.
Morning. All right, as my slides are teed up, there they are, thanks. Good morning, my name is Mike Ter Sluis. I'm the VP of Entrepreneurship at the New Jersey Innovation Institute, or NJII. We are a, wrong button. We are a separate legal entity, but wholly owned by the New Jersey Institute of Technology, NJIT. We were founded on the premise that the most meaningful science and the most impactful technology is coming not from the private sector with this tend towards incremental innovation, but at our nation's research universities. So our mission is to be a conduit between the outside world and the vast resources of New Jersey's R1 Polytechnic Institute, NJIT. So our flagship initiative to be that conduit is the NJII Venture Studio. So it is a $9.2 million investment fund designed to harvest the most impactful IP at NJIT. We build new companies, we in-license that IP, we capitalize those companies to up to $1 million, and we build executive teams to grow and scale those companies. Our first investment, incidentally, is Pure Trace Labs. So it is a next generation PFAS testing company, and it is built on the technology of Dr. Hao Chen. Dr. Chen is a researcher and faculty here at NJIT, and he's developed a novel implementation of paper spray mass spectrometry. And one of the themes we've heard today, I think maybe the theme that I will take away, is what we need, what consumers need, what businesses need are inexpensive and accessible technologies to help them protect themselves, their businesses, their family, the environment against PFAS. And this is what Dr. Chen's technology does. It has, relative to its peers, a lower limit of detection, a reduced per sample cost, and more rapid results. So Dr. Dewan asked us to reflect on what we think is the future, or what are the trends in translating academic research into practical real-world solutions. So I felt there was no better data to show than our customer discovery work. Our hypothesis, our assumption is that today, when a home buyer wants to purchase a home, you receive a seller's package. When you want to purchase that home, it is common for us to expect to see a radon test. Does this property have radon? Well, why wouldn't they also want to know if this property in the water, in the soil, has PFAS? So that's our channel. Our channel is home inspectors, real estate agents, and doing that customer discovery work. We've talked to almost 300 potential home buyers. One of the themes this morning was awareness. Are folks aware of PFAS? And we found that 50% of our respondents are in fact aware. But more powerfully, 88% of them said they would likely add PFAS testing, and 91% would follow that home inspector's recommendation. So if they said, home inspector said, listen, for say $100, would you add this test during the home inspection? 91% of them said they would. During this process, we have generated now over 100 pre-orders. Our CEO, Cassie Halberg, who was here, likes to call that a first world problem because we don't have the test operational at the moment. So a good problem to have, but certainly something we're actively working through. So our go-to-market beachhead is home inspections, but in that same survey, we asked, what if you found out a product you used in your home had PFAS? And of course, 71% said they would switch brands, and 80% said they would pay more for an alternative. I neglected to mention that Hao Chen's technology, one of the differentiators is that it can test multiple matrices. So a fancy word for water and soil. It can also test food packaging, rigid packaging like a baby formula bottle or milk bottle, right? So that gets into what we think the future is for, I think, the space of empowering consumers, but also the future for the company. Our beachheads, soil and water for homeowners, but we can in the near term make several enhancements like new matrices, adding more analytes. Why just PFAS? Wouldn't you want one test that does microplastics, lead, PFAS, right? We have that capability as well. There's an obvious digital layer, which I think Katie mentioned this morning from the state. Of course, we know the provenance of where our samples are coming from. We can create a digital layer for PFAS contamination where it exists in the state and otherwise, but also what products, a product database will have, PFAS in them. Our goal has always been commercial. We want to go commercial. The unregulated consumer side, right, allows us to get to market faster to generate revenue. But of course, we're working towards EPA certification, commercial market entry, and strategic partnerships and remediation. Yes, of course, consumers want to be empowered. They want to be able to know, right, what's in their food, their soil, their water, but they also want to be able to do something. I learned today that ResinTech, our wonderful partner at NJIT, has a home-based PFAS remediation kit for less than $100 that can go under their kitchen sink. So they take our test, they then turn around and can purchase a product like this. So that's exactly where we're going with the remediation side. But of course, we would love to leverage NJIT technology to develop our own organic remediation capabilities as well. So thank you so much for the platform, Atam, and look forward to the discussion.
Hi, I'm Judith Sheff, Executive Director of the New Jersey Commission on Science, Innovation, and Technology. We're a state agency that works to help support academics and early stage companies coming out of academic universities with small grants to help propel some of their development activities forward. We have grants that allow companies to utilize specialized equipment capabilities at New Jersey universities. And now that the federal government has reopened up their SBIR, STTR programming opportunities, there's opportunities for companies to continue some of their development work through those programs. I want to come back because, again, this is all super interesting technology that we've heard about being developed at a variety of our New Jersey R1 universities. And I want to, R1, R2 universities, and I want to talk to our panelists and ask them some questions. So Dr. Lumbach, you've heard some of the technologies that the other researchers are working on. How could you see them embedding some of this longitudinal community health monitoring into some of their research agenda work to help give you some of the data that you need?
Well, as I mentioned, I think there are potential what could be called natural experiments, which they're not natural,
Right.
but they're occurrences of reducing exposure that can allow health scientists, epidemiologists to study the health impact of reducing those exposures. And particularly on responses to PFAS, health responses that are reversible, right? So we think certainly some risks are going to be chronic and long-term. We stop exposure, people still have that risk. But if there are conditions like cholesterol or blood pressure in one of our studies, that those may be immediately or very quickly reversible, and we could demonstrate that effect. And it gives people reassurance as well, I think, that there are things that we can do to improve. Once people are exposed, and especially the long half-lives of these compounds, people are, I think, very concerned, like, what can I do to help myself? I think one issue is with the detection, as we just heard, is like, what is the limit of detection? And will people feel confident that a negative test is really a negative test when the maximum contaminant level guideline from the EPA, from their Science Advisory Board from a year or two ago, was 4 parts per quadrillion in water? So I don't know if anyone wants to comment on that in terms of limits of detection and, but anybody?
Yeah, I mean, I'm going to get out in front of my skis on the technical side of the detection. I would definitely defer you to Dr. Hao Chen, but the lower limit detection on our technology is 1 point per trillion, 1 part per trillion. So that's helpful.
Yeah, so just to add to it, like, I don't think it's feasible to reach that type of detection limit of parts per quadrillion. One of the main reason is like PFAS is very, it's ubiquitous even in analytical labs, right? So you have background contamination. So when we buy these high purity solvents to run the equipment to test PFAS, they actually have trace levels of PFAS themselves. So I don't, it's not realistic at this point. Yeah.
I think Dibs wants to.
Yeah, I think at this time it's a pipe dream. It's not going to happen because, as Arjun said, that again, like even the background PFAS concentration is higher than that, and as such, as I said, like like EPA 1633 method only allows us to like quantify 40 species at this point, and we can go down to parts per trillion, very, very low parts per trillion. But again, like there are so many PFAS species, 14,000 and counting, we have no idea about, right? Like again, and then there are precursors, then there are total oxidizable fluorine, which can actually convert to PFAS down the road. We are just scratching the surface. There is no way we can go down to like parts per quadrillion.
So given the widespread number of contamination and chemicals, and we have some of our policymakers who are here from state government, where should they be prioritizing detection and cleanup efforts so that we're going to have the biggest bang for the buck? So what kind of recommendations would you give to our policymakers and state legislator to say, here's where you should be pushing for things that we could be doing here in New Jersey?
I can take that first.
To help give you some answers, Linda.
Yeah, and I think the obvious place to focus is drinking water quality. So we had a very great presentation from Katie from NJDAP earlier this morning, who also stressed the fact that the exposure of PFAS coming from drinking water supply is very important. So of course, there are exposures coming from other products that we use, like food packaging and clothing. But this can be certainly a place that has to focus from the source, right? So we need to phase out production and so on, which involves so many other stakeholders and players. But I think the focus need to be in drinking water quality at this point, in my opinion. But
Sorry
go ahead.
for interruption. I just wanted to remind audience, if you want to send your questions using the QR code, because I think that after this round, we want to address one or two questions. Yeah, please.
Yeah, absolutely. Like, as Arjun said, that drinking water should be the focus. The thing is that EPA waited for a long time, and in 2024 came up with drinking water standards for 5 PFAS species and then a mix of PFAS species. Then last year they walked back on it and basically said, okay, we are going to not regulate 4 of this, and we are not going to regulate the mix. We are only going to focus on PFOA and PFAS, the 2 long chain PFAS species. Now, the 4 parts per trillion level that exists for those 2 species in a federal level. But thankfully, we are in Jersey and we are proactive about some environmental measures. And we have been, since 2020, we have been implementing a statewide a standard of 13, 14, and 13 parts per trillion for PFOA, PFOS, and PFNA. So there are standards. The thing is that, again, it's going to take a long time for most of the drinking water treatment facilities to actually meet these standards. I think most of the times, the best thing to do is, if you can afford, do under the sink filtration system in your house, and then let activated carbon take out most of the PFAS. But one thing we have to understand that the drinking water is getting the PFAS from somewhere, and most of the time, we are taking it from either surface water, in some cases groundwater, and what is contributing to PFAS in surface water? Think about the wastewater treatment plants, right? Again, particularly the ones which are taking in landfill leachate. Wastewater treatment plants are like a sieve. What goes in goes out. Very little actually gets retained within the system, because most of the WWTPs don't have the kind of facilities that are needed to actually take out PFAS from wastewater. Then it gets concentrated in the sludge, and the sludge becomes biosolid. Then you put the biosolids in the soil, and then you contaminate the agricultural land. So it's a cycle. The whole PFAS thing is a cycle. So again, just focusing on drinking water will probably protect our health to a certain extent. At least something is better than nothing. But there are other sources that we have to think about.
Great. Yes, Dr.
Look,
Jaffe.
yeah, drinking water is probably the highest source of input of PFAS, but we also have to protect drinking water itself. So that means we have to clean up soils that are contaminated, AFFF sites. New Jersey, we don't hear as much as farmland being contaminated at a large scale, but there are many states that have large tracts of farmland that need to be contaminated. The technologies for dealing with one problem are completely different than what you need to deal with another problem. And we're a little bit at a loss, these large tracts of soil of farmland, how to clean them up.
Thank you. I want to go back now to, we've heard about the technology. My one last question really to Michael is, can you talk a little bit more about how the venture studio model is different and enhances what we kind of traditionally think of we've got university technology, I'm going to license it either to a big company, or I'm going to license it to some students, maybe a professor, and hope that startup becomes something. Can you talk a little bit about how the venture studio model really augments capabilities to help technology commercialization be successful?
Yeah, I mean, it's unique in the sense that, I mean, I can only count on one hand how many kind of university venture studio exists, right? So to have a dedicated team that is working to kind of harvest the best technologies, a team of successful entrepreneurs and investors to source the best of what's here and put fuel behind it, you know, whether that fuel is capital, or whether that's a high impact team like we have here with Pure Trace Labs. It is unique, and it allows us to manufacture the startup ecosystem that we want in Newark, right? It's a nascent ecosystem here. A lot of the same faces show up to all the events, which we love. You know, we love those folks continuing to be committed to Newark. But if we want a startup ecosystem here in Newark, we just have to build it ourselves. And there are technologies here at NJIT that can be highly impactful. And the studio is designed for that university setting. So we have high hopes for what we're going to build here in New Jersey, in Newark. So I appreciate the question.
Great. Thank you. Now, Sean has a couple questions or a question.
I've got one question here. We have a handful of them, but I think I've got one here that's good for this panel in particular. So drinking water has been shown to be just a portion of exposure, maybe 20 to 30%, and the rest comes from food and air. So how do we break that chain in human exposure, and what innovations would help us in that effort?
So again, they're kind of saying, we've talked a lot about water, and I know Dr. Jaffe, you mentioned, you know, some of the soil remediation and, you know, in other places. What are some of the other technologies perhaps that we've got to take a focus on to break that circular piece that you've all talked about?
I mean, sorry, I would take the question, and of course it's a plug for Pure Trace, but I think people want to act today, right? You know, and they want something to give them the information, even if we don't have the remediation side here and ready. You can at least give people the information to know what not to choose, you know, what not to purchase. And they want to be empowered, and to the degree that we can give them solutions today that are accessible. That's the theme to me, right? Affordable, accessible, empower consumers today to make the right choices for their families. I think that's the immediate kind of go to market for all these technologies.
Anyone else? Dibs?
Well, again, breaking the cycle is almost impossible. Sorry to be so pessimistic, but PFAS is everywhere. You know, Peter talked about the soil contamination of PFAS. You know, I think in 2021, USDA published a report which said that 20 million acres at that time of farmland is already contaminated by PFAS. So what are you going to do with that? You know, again, that PFAS is going to be there. If it's mobile, then you are screwed. You know, it's going to leach to the groundwater, or the plants are going to take it up. Okay, again, there was a report in Texas, you know, that a farmland was so contaminated that the PFAS actually ran off to a pond, and calves started dying. And when they saw the calves are dying, they tried to figure out what was happening. They contacted a environmental reporter who brought it to the attention of a lot of people, and they found that the calf's liver had 600 parts per billion of PFAS. Okay, and then they tried to figure out how the hell did it happen, and then they found out that the source was Synagro, which was a Class A biosolid that was applied in that land for the last 10, 15 years, and PFAS accumulated in the soil, and it was taken up by plants. Okay, so that's so the best thing that we can do, instead of thinking from that you know, level, very high level of how we can actually break this cycle, we have to go for point treatment, you know, for example, what we can do to protect ourselves. Okay, again, do we get a filtration system at home if we can afford it to get rid of PFAS? Do we force our regulators to actually make sure that the 4 parts per trillion level that they have come up with for certain PFAS species, they are strongly implemented? So that is what we can do at this point, instead of, you know, thinking about doing, we have to think long-term, there is no question about it, but at this point, like, I think the problem is much more closer to home than anything else. We have to protect ourselves first.
I think Dr.
Oh.
Jaffe wants to,
Just one.
I think that would be the last.
last comment.
Multiple reports have shown that PFAS in rainwater is much higher than in drinking water standards. And so we need what was mentioned earlier, air pollution regulation. And we cannot break the cycle of land and farmland and products that we ingest being free of PFAS if we don't regulate the air pollution.
Thank you. Well, this has been a really exciting conversation. I want to do a quick plug for a website that the commission manages called Research with New Jersey. It has information on 7,500 New Jersey researchers, publications, and so forth. You put in a search term, and it's going to come back and tell you who are faculty working in those areas, what are some of their publications, what are some of the grants that they've received. So if you're looking to be able to collaborate with folks from these universities as well as other people from NJIT, and I see some other colleagues from NJIT. I see Dr. Michelle Bufadel, Wumi Sadik, some other great researchers here. You'll be able to help find connections to be able to work with them on challenges that you have. Let's give the panel a big thank you.
Thank you.